everyone, again. We all gathered here today for a lot of exciting things, and I'm going to talk about designing for wearable AR. But before, I'll introduce myself. I'm Daria, and I'm leading visual design for Specs. Through my career, I actually had quite a mix of different experiences. I started as a 2D artist. I then switched into 3D because I was like, okay, 2 axes was not enough for me. I needed some space. And then I also tried animation and 2D animation, 3D animation, and I did some concept art and VizDev. And I was like, wow, that's a lot of different things. But then actually, thanks to that experience, I ended up at Specs, where I am right now. And I work on a lot of exciting things. I mostly focus on SnapOS, but also I do a lot of different product renders, some animation, sometimes even a chance to art direct some lenses. So a lot of exciting things. And today, we have a pre-packed agenda. We'll talk about some design guidelines. We're going to talk about the field of view, the colors, how to work with additive display. We're also going to cover some things like 3D and animation, some shaders for like Lens Studio. And in the end, we're also going to have some time for Q&A. We're going to start from design guidelines and why actually those things matters for wearable design. I can actually probably name way more reasons than those, but I'll start from here. Those are the most important as for me, because the first thing, we're actually switching from 2D canvas to the whole environment, the world around us, and that's a very big change. Another thing is that now our hands are actually free. So that introduces way more different opportunities for us as for designers. And actually that leads us to the different input types, because besides hands and voice, now we can do so many other things, right? Like there's so many other inputs. When we're talking about the canvas and environment around us, the content is not attached to the screen anymore. It's actually in the world around us. And that means more opportunities, more freedom, more creativity, but also it's getting a little chaotic. Where do I start? Like, what's the new rules, And when we design our experience, it's important to think about how we position our objects and the content in the space. We have to think about where the objects are they intersecting with the real world objects? Because again, the AR objects are not real. However, we have to make sure that the environment is safe, and that's becoming a part of the early design work that we have to do for experience that we're working on. Is it a game? Is it a utility? It doesn't matter. We have to make sure that the content and the environment is safe for our users. We actually recommend to use the certain distances for the near field and the far field. If you design for near field, the most comfortable distance is 50 to 60 centimeters. If you design for the far field, it's around 100 to 110. And there's a question, why exactly those numbers? We'll do a little math here, but just tiny little bit. It's like, as you know, spectacles have 2 displays. And for each eye, and we project the image, and then we actually have a complete overlap at a distance of 110 centimeters. What that means is that this is the exact place where the content is the most crisp, sharp, and has the best comfort for the eyes. You can also see that the size, that green area, is like, it's actually a field of view, and it has a physical real-world sizes, and that's also really important because when we design for AR, we work with the Lens Studio and we use the real-world units, so we actually can plan the size of the content accordingly to the place where you position those. And then we can consider it like way more different input options for our experiences. When we interact with the phone, we mostly use hands and voice, but also, again, it's not at the same time. However, when we design our experience for AR, we have a couple of more options. And how to pick which one to use, it's really actually depends on the experience you build. And again, I think that's a consideration for a very early design stage. For example, if you build the experience for the gallery, you probably don't want to use the voice as a main choice, because imagine all those people getting distracted by you talking to your specs in the gallery. However, you can also be creative in your experiences and like, hey, I have a dinosaur, and the interaction will happen when I'm gonna come close to it, and it's gonna start roaring me. So my device position can be an input type, or the other object, or I can actually talk to that dinosaur. It's like, hey, how are you doing? And it's gonna roar at me. So we can combine different inputs, and that's something that also we should probably plan accordingly in the early stage, because all of this flow has to be tested with the different inputs and transitioning between them on a very early stage of your design work. And as you probably know, we support both direct and indirect interaction paradigm. Our main gestures are poke and pinch, and basically how you define what gesture to use is pretty easy. If it's near field interaction, you probably want to poke, it's very natural, or use the near field pinch, which is also an option. If content is positioned further from you in mid to far field, then far field pinch is the best option for you. There is no need to come closer to the objects. We can just switch to the far field pinch. All this math is actually, lucky us, we don't have to think about it that much, because we have something like SAK and UIKit, which actually SAK does all the job for us. We just need to unpack it and use it. However, we also have something to help on the design side. We released UIKit, and we also have a design kit on Figma that basically has the same elements that you guys already probably seen in UIKit. So those are already, it's like a set of design system basically that we used for a lot of our experiences in OS that you can just also use for any of the experiences that you're working on. I think it's like speeding up the work, especially in the early stages when you're figuring things out. Do you want to use your custom UI, or you want to just like use something out of the box? That's a great way to start. So the field of view, we all already know what the field of view is. However, just a couple of things to consider is when you design your experience, it's important for UI to be visible. This is really important because users already it's like a new thing. They're figuring out what to do, how to interact. But UI is something that has to be there all the time to support and help to go through the first time experience. The content doesn't have to be visible in field of view all the time. It could be partially hidden. However, it's up to you to decide how it's going to be positioned. Just mind if the content is around in the space, around in the environment. Make sure that you have enough guidance for the user to discover all of the content, and just try to make sure that at any moment of the experience, user is really confident what to do next. When we think about UI, we recommend to position it. There are three main types of UI anchoring. Basically, you can anchor to the hand, you can anchor to the body, or use the spatial position. It's also relatively up to you how you want to do that. Some of them beneficial, for example, for the games, it makes sense to use a lot of spatial options. Like it can be, hey, I found the chest, I opened the chest, there's some loot. That's a good use case for that. I mentioned additive display. The darker colors are less visible. The bright colors, way more intense and more bright on display. And this is really important when you pick the theme and the colors for your experience. If the object is too dark, it might be less visible. If it's black, it's not visible at all. However, it doesn't mean that the objects are not there. And that's actually, I kind of use it as a tool. I hide a lot of things that are actually there, but they're just like not rendering. And where is that useful? I'll skip that for now, but the shadow, we know, oh, like you can render black. However, I use that trick to put the backplate behind the buttons, and then I use black as a drop shadow, and I have that nice shadow effect. So we can play around and be creative with those limitations of the additive color space. Just be mindful of the colors that you pick for your experience. And when we talk about some other colors that we want to be careful with, I would say be mindful of how you use the white color. It's tend to be the most luminous and bright on display. Means that if you have a bigger objects that have a white color fill, that might be a little less comforting for the eyes. So we have to also be ready and prepare for those. So think ahead. It's like what color I'm using. If you have a big bright objects, my recommendation is to tune down the brightness to 80–90%, and that will get to the comfortable level. If you use the text, again, text is better to use white text on the darker backgrounds. It's way more comforting for the eyes. And picking the 80–90%, it also works there because you leave a space for that 10%. For example, if you have an interaction on hover, it's nice to kind of emphasize that and add a little bit of that 10% to that text on hover to make it pop for the user and kind of like direct that attention. And for the hue, another thing is just, I made it smaller intentionally, but the difference between blue is like around a different degree, 30 degrees in hue, and you can see on display that actually there's like a difference between those two colors, and it's really clear. However, on the red side, it's like only 20, and you can see on display that it's like challenging. If those are your main colors, just to make sure there's a little bit, like around 30 degrees difference in the hue, so it makes like really clear for the users that those are two different colors. It matters if you actually building for like outdoor experiences, because again, we have a very intense environment map. I mean, the light, the sun and everything is like that affects how you see the colors. So like, just remember this. Basically, the summarizing of what we talk about, just when you design an additive, just keep in mind those couple of points, like how do I use black and white? Is there enough like a color difference in the plea that I'm picking? And basically, don't pick too many colors, because again, the overlay, like how we see the colors on display, there's so many other colors as a see-through. Do we want it or not? Is like, it's mixing with the environment. So picking less color variety might do a better job for your experience. But again, it also really depends on what exactly you're building. If we're talking about games, obviously, it's more like a rule for UI elements. When we talk about UI and what to pay attention to is a really important thing as ergonomics of interaction. I would say, again, doing the motion, like, using your hands might be a little bit tiring. So I recommend you guys to position the toolbars or maybe the elements that you want users to interact with all the time in the lower area, because that's a less range of the motion. Things that destructive, or you want to make sure that it's actually a clear intent to do so in the higher area. For example, like I always separate like close button and delete button in the different corners in the higher area. The reason for that, I want to make sure if my user wants to delete this, because it's like a destructive operation, so you cannot undo that. So I want to make sure that that's going to be a motion that my user really like have to go there. It's intentionally. And the close is going to be in the opposite direction, because I don't want to close and delete to be together. I want to leave some space, especially for experiences that could be, you can do on the go, like when you use the device. You want to make sure that it's very intentional what the user is about to do. And some recommendations, of course, you guys all know about our Reddit, but I also want to mention Alessia's channel on YouTube. I love that source of information. I learn from it a lot, too. So just a lot of questions that you might have after all those talks, and just any moment, you can ask anyone on Reddit, or you can also check out some very useful tutorials from Alessia. From here, we move into my favorite part. We're going to talk about 3D and animation. And you might ask me again, why does it matter? Because the moment we open Lens Studio, everything is basically a 3D object in the shader. Even image is a shader. We'll get there. But again, when we switch into the 3D environment and we position things in space, basically we sooner or later are going to start working with 3D objects. And it's important to understand some basics. And that's like a very, very like huge discussion we can have for a lot of different like, occasions. However, I just want to give you a couple of points where to look for information, how to debug, and how to understand when when you should pay attention on, how big is your model, how to quickly optimize that to make sure that your experience runs smoothly and fast, and, because we all want our experience to be performant and fun for the user, and users are not getting that much fun when they wait a long time for assets to load. So the better you're optimized, the more you can add, and I'm a very old school in 3D, and I know that for sure, and I believe the better you optimize, the more stuff you can put in your experience without using remote assets, because that also, like, you need to check if you connected to Wi-Fi and all of those complications. But the good optimization leads to a lot of possible content you can pack, so that's important. And another thing that is automation. I know it's not really obvious why we talk about automation here, but again, we're switching into a new design medium, which is like AR, designing for AR. And a lot of things there actually make sense. We'll talk about it. But before I'm going to talk about the software, I made this deck using a lot of examples from Lens Studio and Blender. I don't need to introduce Lens Studio that much. You're all guys familiar with that, and you all use it. It's amazing. However, I just want to explain the choice of Blender here. First of all, Blender is free. So everyone who never tried 3D and you want to start from somewhere, I think it's a good choice because you don't have to think about like a lot of different questions. And the other thing, every question you might have, it's already answered. There's so many tutorials available for that. So any moment you're stuck, you don't feel pressured about it. It's like, how do I do this? You just Google, it's less than 1 second and you have an answer. So that's basically it. Okay, first is a polycount. Polycount is a number of triangles or quads in 3D model. It's basically how we talk about how heavy is the model. That's why we need it. It's just someone tells you it's 1 million polycount of the model is 1 million, it's super heavy. It's very heavy. Someone tells you it's 30,000, it's good. Subdivision and decimation, those are two opposite processes. Subdivision is when we actually increasing the polycount, and decimation is when we're decreasing the polycount. UV is a way of projecting a 3D model into 2D surface. Why do we need it? For texturing. Why does it matter? For shaders in our case. Basically, think about it as like a wrapper around the candy. If you unwrap it, that's a UV. It's very simple. It causes a lot of confusion. What is rig? Rig is a 3D skeleton. It's basically a bone structure for animation. We don't need it that often, but we just have to talk about this as an option. And a blend shape is basically another way to animate the object as a deformation of the mesh. It's amazing shit, how to not use the rig in complicated animation. I do most of my animation through the blend shapes. It's fast, it's easy. Kind of can get expensive, but we'll just skip that for now. A question, to model or not to model? I know right now with AI, everything is like really different for like in our workflows. However, again, I'm very old school. I think it's important to think about this a little bit. We can actually just get the models from Marketplace. It's one way. It's absolutely cool. We can make it yourself. It's an amazing option. And we also can use AI-generated assets. I think it's great. The only thing you have to pay attention is up there, the topology, the vertices. You see, it's very big. You're gonna put one of this bowl in your experience, and that's good, maybe. That's maybe what you want. However, okay, you decided to pick AI-generated stuff. So what to do next? We will decimate, but before that, we talk about subdivision. So again, it's a whole class, it's a whole semester talking about how to optimize the models. It's really complicated, but my to-go tip and trick is, so we have 3 buttons, right? There's like 256 trees, 1K, 4K. How do I know when it's enough? Like, basically, just look at the silhouette. Like, I can see that my button on 1K, like, 256 looks a little bit like meh, but then 1K looks like a silhouette how I want it. If the object looks how you want it, that's good. You don't have to go higher. There's no reason for me to go 4K. I can just stop there. The same with the decimation. Blender has like a very cool modifiers that actually do all the work for you. So before, it was a very tedious, like a long process, but now we don't have to think about it. It's just like click and go. So again, I got this model. It was very high poly. You can see it was like 550,000 whatever thing, really expensive. I just added modifier, decimated automatically. It ended up being 40K, which is very easy, very fast, very cheap. We don't have to do much for that. We can do that obviously manually. Hand retopology, that's, if you like it, you do this. If you don't have time, that's totally fine, especially in the early stage when you prototype experience. You don't know exactly what would be your final like set of maps for whatever game you're making. So you just decimate it automatically. Cool thing about it, it actually preserves your rig. So you have animation. Before, it was like, you can't imagine, guys. It was like, you can't touch the rig and skin mesh. You just look at it and it breaks. But now you can just automatically decimate it. It's cool. It's gonna save everything you have. So even animated meshes, good to go. So just a couple of numbers. I mean, it's relevant, but it's not that relevant, but you also have to think about it. 60K poly count character will weigh around 161 megabytes, right? And then if you look at it, the difference between 16 megabytes and 8 megabytes, 20K and 7K, it's not really noticeable. But for you guys, 7K and 20K, you can actually, it's like a price of 3 characters in one. The mesh can look very like optimized, but that's how the mesh look like on those models. And it really depends on the size of your objects, on models, how you use it. Is it like a full scale, the same height as me character? Yeah, of course, you have to go higher. However, think about LODs, level of details. If your characters are small, objects are small, and they like somewhere out there, just go like even more low poly. And then just like when you move closer, then update the model. It's all the same stuff that it was like 10 years ago when we did the game dev, the same rules working here. And why do we need UVs? Basically, UVs are mostly used for textures, the texturing, and if you want to go fancy, you like do all those manually. I did it manually, I think. But also, again, today we have so many different plugins, again, in Blender, even the free options. You can automatically unwrap that, save some time. You don't have to stress out about how am I gonna do this, because that's a very long process manually. It takes time. Again, some people enjoy it. I like doing UVs. It's very like stress relief thing. We will use it mostly in shaders, and we'll talk about that later. But if you guys build in games, sooner or later you'll have to face it. Automatic UV unwrappers is a good way to go. So switching to animation. So as we know, we all designing things that in AR means they don't exist in real life, right? When we talk about the buttons, if we're talking about something like a keyboard, I can look at it like, we kind of like when we interact with things, we use a different senses. Like I look at it, I press it, I can see the button go inside so I understand, I can hear the click, I can feel the button, I can see how it moves. So we kind of like, we don't think about it much, but that's how it works. But we have buttons in AR, so they don't exist. You can't touch them. They're not real. So what do we do about it? We can do a couple of things. I just fake everything with animation. Fake it until you make it. So I use sound, I use animation all together to make that feel that you press the button. And another trick is like that button was located on the palm, so actually I can feel the touch. So it helps me to simulate that press of that button. And it's really important to, the animation plays a really important role in those because it helps user to understand really clearly what's going on and feel that connection to the objects that are not real. And I know it's like sounds like an extra effort, but believe me, that button was really clear for users. And it worked really well. Everyone understood right away what you have to do and when it's like pressed. And I used blend shapes here actually. So I deformed the button I used 4 different blend shapes. Every side had a separate deformation. And then just connected SAK, and I used the colliders to actually detect the direction of that and just make it like really, really squishy. Always that probably all different type of animations that you're probably gonna use. We can use a rig basically, but again, it's more like for or complex objects like different robotic stuff and like obviously characters. But again, it's high effort. However, it's an option. I actually built the first version of this button with the bones. And the reason for that, I just simulate that shake animation. And then I just bake that, and I use that for early prototypes, but it's absolutely unnecessary. And then blend shapes, basically, it's a mesh deformation, doesn't require any setup. You just like squeeze it, and it's done. And the simulation, obviously, you can use physics. I added physics to this button to actually shake my hand and see if that's fun to do, but it was very distracting. It's like just people just like shaking that button, and I'm like, no, that's not what you do with this. I mean, it's fun, but it's actually UI. Okay, cool. Shaders. I think this one is like the most questions is usually about the shader, because it's like a very complex territory. Why are we talking about shaders? The reason is really simple, because the moment you open Lens Studio, everything is a shader. Even image, you just drag and drop an image, it's actually automatically wrapped into material, which actually connected to the shader, so everything is a shader. It's controversial, we can talk about that more, but shaders can be way more expensive than the actual mesh. And we just have to understand where is the territory. There's like, that cost me 10 characters or one shader, like that's basically what we have to know. Obviously, shaders are responsible for the like look and feel of everything that we see in Lens Studio environment. When we push the lens, everything is a shader. That's why we have to know what it is and how to deal with this. Because if we don't understand what is underneath there, then we don't know when it gets heavy. Sometimes I see amazing projects and they have just like very expensive shader. You can pack 3 times more, but it's just the shaders. So what is shader? Shaders everywhere. Shaders is everything, but actually shader is a tiny little program. Basically, that's it. We don't have to know about this much, how it built and all of those. What we have to know is that every software has their own shaders. They usually not cross-platform. You cannot export shader from, in most cases. You cannot export shader from Blender and send it to Maya. It's not gonna work. You cannot export shader from Maya and send it to Lens Studio. It's not going to work. The reason for that, because every company has their own way to compile those. So basically, shaders divided into groups. It's everything here is actually like with a little star there, because like there's way more to that. But I just need to keep it very, very short and just focus on the things that I mostly see people use building like for AR. Procedural. Those are the best for us. Everything else is like everything we see in movies. It's baked, it's rendered, it's like, it's not real time. So procedural, and basically traditional include all the texturing. So if I have the shader for my dinosaur and I'm gonna attach it to another dinosaur, it's not gonna work because that one used UVs, it mapped for a specific UV, different UV channels and all of this. Procedurals are different. You can apply it to anything. It's gonna look the same good. It's all used like a math. There's no textures in it, mostly. It could be some noise textures or something, but those are tiled. For Lens Studio, we'll be talking about PBR, diffuse, and unlit. There's more to that, but we'll start from there. The shader can look very different. The hair is also a shader. So this is an example of just out-of-the-box BSDF shader in Blender. This is example of Lens Studio shader. You probably all seen that. And some really cool procedural substance painter shaders. They're using a lot of, this one used like bump map. So we can see it's all like, actually looks like a real mesh, but it's actually a map. This one is actually just using a texture. So it's not even a real lighting, it's just a baked light. There's so many different options. It's just impossible to even collect them in one place. It's just like endless possibilities. So in Lens Studio, we use shaders and materials. In different software, you can just find, someone says, oh, it's all materials. Someone says it's all shaders. Different software, different things. But in Lens Studio, we have shader and material. And it's really cool in a way that shader actually contains all the logics. It's like all the nodes, all of that, it's a shader. And then material is something that actually, you can use multiple materials for one shader. You expose the parameters in shader, and then you attach multiple different materials. And that's how you kind of optimize in a way, but also it's like keeps your project clean. For example, here, it's all one shader. All those images is a one shader, but I use a lot of different materials. You can see it over here. It's like 20-ish And the shader is really simple. I just don't need much. I just need a texture and multiply that and cut out the alpha, and that's basically it. And then I have a lot of different images, and I'll just duplicate the same material that will reference the same shader. It's very easy to organize and optimize. You know, when you use Lens to Do, you probably like in most cases, you try to use Uber shaders, but I just want to kind of like talk a little bit about different approach with Uber shaders and custom shaders. So Uber shaders are great. They're very easy to start building with. Everything is there. All the opacity, different UVs, like everything you want, it's there. You don't have to basically do much. Just attach your textures and you're ready to go. However, if you're gonna look in that shader, it's actually pretty much packed with a lot of stuff. Really good for prototyping early stages of your project when you don't care about optimization, you care about how fast I can get and iterate until it feels right. But after that, consider to spend some time actually building your custom shaders. In most cases, it's gonna be way easier for you even to build from the scratch than just work with the Uber shaders, because there's so many things that later when your project grows with the complexity, you're just like, oh, it's like so many things there. Building custom shaders is fun for some people, but I just like doing that. It's like, it makes me feel, it's like, oh yeah, I'm gonna do this and that, and it's like so nice and organized and clean, and it's like optimized. And then I'm like bringing that to engineers, and they're like, oh look, it's such a nice shader, and you know. Anyway, the different type of shaders, right? We're gonna talk about physical-based PBR, physical-based render. That's what PBR stands for. What it means is actually like a true real math, right? So if you put the PBR shader on your object and say, hey, it's metallic, and actually for real will calculate the effect of the environment on that object. So every single millisecond frames, whatever, it calculates, it measures, it actually represents the real physical properties of the object that you're making. So it's true, it's honest, it does the work every single frame. So it's very expensive, but it's cool, it's cool. You know, it's cool, just think about it. Do I really need to calculate that? The other option is diffuse. It's a way better option for us because diffuse is way less expensive. It doesn't calculate a lot of different properties. It's just calculate the light. So it's way cheaper. It's a go-to option for most cases, I would say. Then there's unlit. The name actually explains what it is. Nothing affects it, it's just the color. I would say for me is a to-go option. I fake a lot of shaders. You can look at it and say, oh, that actually looks like a real glass material, right? It looks like PBR. Wrong, it's unlit, and I always fake my shaders. I never use PBR, even though I really like it. That's my biggest secret. Use a simple reflection and matcap. What those nodes actually do, they take an image. It's not a shader, it's an image. You go to any software, you just screenshot the material on the sphere, and you use that image, and it projects it on your object. It sounds like too perfect, right? It's like, it's cheap. You can use like hundreds of those materials. It looks amazing. It's a real glass. It's a real gold. There's no trick in that. It's 4 nodes to make it. Sounds very good. Yes, it is. Works for UI elements, works for the objects. If you look at from the one side, the trick is if you're gonna walk around that object and look from the back, because again, it's a projection of the texture, it's not a real thing, even though we can say, yeah, it's real, there's gonna be a seam of that texture on the back. So there are so many ways how you can actually deal with that. You can, I mean, if you have a game that you're building and there's like characters and environments, you're walking around, yeah, don't do that, don't use it, because like the moment I'm gonna walk around it, I'll see that seam. There are some tricks that you can use. You can actually like cut some mesh out of there, and it's like where the seam is, like if that's allowed for the buttons or something like that stays on the surface. So the seam is gonna go there, and it's like you can hide it. However, just like for UI, 100% go to any objects that are gonna be billboard to you, 100%. Just mind that, you know, check around if that looks good to you. Okay, a couple of examples. I'm still like trying to just like deliver this idea. It's like, hey guys, invest in shaders, like build them yourself. It's easy. I know it's not, but you want to just attach the texture to your object. Basically, those 3 nodes is just the way how the texture is connected. It's not like my shader like has all this math. It's like I'm taking the custom map, whatever the texture I have. I take the UV coordinates of my cube because I want to put it on every surface and my cube is in rep. So basically that's what I'm telling. I'm combining those 2 and I'm sending that to shader. That's all it is. If I don't want to use UV, I don't even have to do it. I can just use the textures straightforward to the shader, that's it. But I want it to be nice on every side. Another example, I know the choice of colors is very questionable. However, believe it or not, 90% of my shaders use gradient and this approach. With the better color choice, obviously. If you want to do a nice button, you can actually use different colors to make all those gradients, and your experience will not pass UXR with those colors. However, if you just look at it, it's like 3 different nodes. Basically, I'm taking, again, this UV. We always take a UV of our objects. That's why it's important. And then I'm just scaling it because it can be like very big or very small. Basically, that's all you do. And move it a little bit to actually get to the spot you want. And then you take the vector of it, and it's basically connected to gradient, and that's it. If you want a linear, you don't even have to do it. Just tell the UVs of what the UV of your object, and you're good to go. This is how this is basically the shader that I'm using 90% of the time. The rim is already even packed in the separate node, so it looks really good. It actually makes the nice outline around your object. It's always gonna move, so it always looks good. What I do, I'm setting the color for the object, and I connect the rim, and I mix it with the color that I want for a rim, and that's it. And I mean, there's way more to that, obviously. After all this talk is like a couple of things that I think is important when we design for AR. I start design from 3D. I don't design in 2D. I jump right away in blocking and putting things around and see if that feels good, if that's easy to interact, it's easy to discover, is it fun, and all of those. And before diving into all of the, like, how cool my button will look like with this amazing shader, I know it's a fun part, but the reality, like, I was a 3D artist for a really long time. 90% of the time, I'm looking at the gray box, and it's like, until a very last moment when you connect all the textures, you high poly, low poly, your topology, your texturing, everything looks gray. It's depressing, but it's fun. You can find the fun in that. So prototyping in gray mud, in cubes, in simple shapes, you can select the different colors. You can have some fun with this, but it's really important before you dive into visual design, into design phase, because the design starts from interaction for AR, where the objects are, how the UI looks like, what's the flow, the user flow, and that's as fast to iterate when you use a simple primitives, rather than you have all those cool buttons, but it all looks like it doesn't make sense together. Since we're all using Lens Studio, they everywhere. They can save you a lot of resources. Your projects can be 3-5 times bigger if you optimize your 3D and shaders, and basically, it's a very worth of your time. Thank you.